Hello, this is Miss McCauley, and this video will be teaching you how to complete and create ratio tables. The video was created by a teacher named Miss Zach, who was a student teacher of mine several years ago. If you have any questions, please make sure to ask your math teachers.
Hello, so today we are going to talk about ratio tables and equivalent ratios, actually not ratio tables. So we're going to go back and review some things about ratios that you learned in step 2. And it's kind of similar to unit rates because you have to almost break it down a little bit, but we'll get more into that in a second here. So, what is a ratio table? A ratio table is a table because the columns are filled with pairs of numbers with having the same ratio. So is a table where columns are filled with the same ratio. Okay, and remember that ratios have to share a common unit or label. Okay, so we will get into some examples of those in a second, but I just wanted to give you guys a definition of what that is. Okay, so our next definition to cover first are equivalent ratios. Okay, now if you remember, equivalent ratios express the same relationship between quantities. Okay, so that would be similar to saying if I had, let's say I had soda and juice. And actually I'm going to write that in different colors so you can see it a little more because this is kind of an example. So we have soda and juice. Okay, and so let's say I started out with 1 can of soda and 3 cups of juice. Equivalent ratio would mean that I'm going to multiply the same thing to my soda as I am to my juice. So if I had 2 cups of soda, or 2 cans of soda, how many cups of juice would I have? Now if you said I had 6 cups of juice, you are correct. Okay, so now if I had 3 cans of soda, you're probably thinking you're going to have 9 cups of juice, which again, you are correct, okay? So it's kind of like fractions when we're making them bigger, okay? What you do to the top, you have to do to the bottom. So that might help you a little bit if you think about it that way. So now we're going to do an example, okay? So this says, to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring would you mix with 5 cups of icing? Okay, so what I like to do is I like to go through and figure out what some important information is here. So if we go here, we have 6 drops of yellow food coloring, okay, and that is used to make 1 cup of white icing, and now we want to see what happens if we make 5 cups. So I think that the best way to do this is probably to make a table. Okay, so I'm going to make my table down here, and we'll come back to look at that in a second here. So I'm going to just draw it like this. Okay, so then I'm going to call this drops of yellow. Okay, draw this line here. We're going to call this one cups of icing. Okay, now if I go back up here, our original problem said we mix 6 drops of yellow food coloring, so I write 6 down in here. Okay, with 1 cup of icing. Okay, so now we want to make this an equivalent ratio, so I put a 5 down here because we want to find out how many drops we need for 5 cups of icing. Now what did I do to get from 1 to 5? If you said multiply this by 5, you are correct. And as I mentioned earlier, it's similar to fractions when we find a common denominator. What we do to the bottom, we have to do to the top. So what we're doing to the bottom of this table, we have to do to the top. And I multiplied by 5 here, so now I must multiply by 5 here. 6 times 5 is 30. So my answer would then be 30 drops of yellow food coloring. Okay, and I'll just box that out a little bit so you guys can see that. Alright, and again, to get from 1 cup of icing to 5, we multiplied 1 times 5. So then if I get to 6 yellow drops, I have to figure out how much I need. So I multiplied 6 by 5, and that's where I got my 30. Okay, so that's an example of a table and also using equivalent ratios. Okay, so now we're going to, oh no, sorry, we have another example we're going to do here. Okay, so this one's going to lead us into something called scaling that we'll talk about in a second here. So we said Joey Chestnut won a hot dog eating contest by eating 66, okay, so I see this already, so I think I'm going to underline it because it might be important, 66 hot dogs in 12 minutes. If he ate at a constant rate, find about how many hot dogs he ate every 2 minutes. Okay, so we're just going to move this up a little bit here. And I think that, again, we might probably make a table. Right, so let's make this one blue. So we can make this here. Okay. And I think we're going to say hot dogs up here, because he ate hot dogs per minute. So the per tells us it's at the bottom of our ratio. So we have hot dogs here. And then we have time, and then specifically in minutes here. Okay, so we know right off the bat he ate 66 hot dogs in 12 minutes. Okay, so now what I want to do is I want to make this smaller. I want to figure out how much he ate in 2 minutes. Okay, so 2 is our end goal, but I might not know what I have to do to get from 12 to 2. So let's make this just a little bit smaller. So if I, let's divide this right here by 6, okay, so divide by, or not by 6, let's divide this by 2. So then I get 12 divided by 2 is 6, and what I do there, I have to do up here. So then I do 66 divided by 2, which would give me 33. So in 6 minutes, he eats 33 hot dogs. But that's not enough, because remember the question wants us to find how many hot dogs he would eat at a constant rate within every 2 minutes. Okay, so now I need to somehow get from 6 to 2. So what can I do to get from 6 to 2? If your answer is divide by 3, you are again correct. Okay, so 6 divided by 3 is 2, so that checks out. So now we must do 33 divided by 3. And our answer is 11. So now we know that Joey Chestnut So we can say, let's say, Joey eats 11 hot dogs every 2 minutes. Okay? And ratio tables are just an easier way for us to show our work and display the information we're trying to get to. You can kind of think about this as like trying to find the greatest common factor between the two. Okay? So if you could easily see right away that 6 goes into both 66 and 12, then go ahead and divide by 6. You don't have to take those baby steps of 2 and 3. But if that's easier for you to do 2 and then again do 3, that's totally fine too. There's no right or wrong way to simplify these things, okay?
Okay, please write out a ratio table to show how you would answer this question. Show your teacher when you have finished this part. If a sixth grader can complete 60 math questions in 20 minutes, how many math questions can they complete in 5 minutes? Please show your ratio table to your teacher when you've finished before moving on to part 2.